Welcome to my laboratory. Today I want to present principles of the resistors in a real-life application. That's the first one, 220 kilo ohms. Let's take it. You can take a look. Those lines, of course, as I showed before, are representing the actual value of the resistor. So let's prepare it to make that fit into the breadboard. But maybe first, to be sure, we can measure the actual value with my universal tester. And the value is 221.3 kilo ohm. .24 input voltage, and at this moment still 0 amps, of course, because nothing is connected yet. So I will take my pins. Let's connect them correctly. Yes. And that's the moment. At this moment we've got around 0.04, 0.05 amp flowing current. Let's measure the voltage drop, which almost equals the input voltage. It is so because there is a small difference between measuring devices. Now on the screen you can see equation to reveal the resistance, so we can calculate then that the flowing current is a 46 milliamps. Let's try another test. I will add another one, which has exact same resistance as the previous one. So now we can see that the flowing current is 0.02 amp, so 20 milliamp. Let's measure the voltage drop then. 5 volts on the first one and 5.15 volt on the second one. We can also add a third one. And what we will get then? We will see soon. So let's take a look now. Now the current drops to the 0.02, 0.01 amp. Let's measure a voltage drop. Now it equals 3.3 on the first one, 3.34 on the second one, on the third one 3.43 volt. So we can also measure that the flowing current should be around 15 milliamps right now in this circuit. Let's try something else then. Now we will try to connect resistors in the parallel. And let's see what will happen then. What it will cause. Now the current rise a lot, because now we have 0.09 amp, so 90 milliamps. And the voltage drop on resistor equals a input voltage. That's the equation for revealing the actual value of the resistance. So in this case it was 110 kilo ohm. And now we can see a flowing current in this circuit. Let's try another two resistors. Measuring the first one. it's around 470 ohms. Let's measure the second one. Oh my god, what happened? Don't worry, we will fix it. So here we go, 101 ohm. Let's measure the actual values on each of them. Of course, as we measured on the tester previously. So now connect them in parallel. And repeat the measuring once again. The first one is 82 ohms. Second shows 91 ohm, 92. So in general it should be together 83.1 ohm. Many of us are curious which resistor should be used in LED circuit to avoid damaging LEDs, of course. Now on your screen appears the scheme with the calculations. I already have a chosen one, so let's take a look which one I choose. It's a 469.6 ohm. Why so? You will see soon. Let's connect it together. Of course with the right polarity for LED, that's very important. And this is it. Now, flowing current is around 17 milliamps, which is great. 2 volts power drop or voltage drop on a LED, 7.75 volts on a resistor. Now we can test what will happen when we will play a little bit with the voltage, input voltage, when it drops to the 7.4, or when we rise a voltage up to 14.2. The flowing current is still in acceptable range. Let's set the same voltage as previously. Why we shouldn't add extra LEDs to make even more light, to make it more brighter. Of course we are connecting them as a parallel connection. Oh, and then one more extra is shining. And the third one as well. Mission successful. The current little bit rise, but not just a tiny bit. So now let's measure another resistor. Which is 101 ohm. Measuring the second one. this one is presenting 470 ohms. Let's connect an insert and measure actual values with the multimeter. First the first one, which is around 100 ohms, and the other one close to the 470 ohm. Both together 567 ohms. Let's conduct another experiment. Give me a second. So we are powering everything. First a power supply, later a minus, and we can see that on the first of the resistors the voltage drop, if I will set it correctly of course, voltage drop will be 1.77 volt, and on the second one we are talking about 8.28 volt. What we can do, it's called a voltage divider. Now the voltage is divided in two different values. So with the voltage related to the first resistor, we can just power the LED, and that's super fine. Second one still has 8.3 volt, and that was all. Let's focus on the other case. Again, a parallel connection, sorry. And so I'll just power it on. Now we are talking about higher current as the equation to reveal the power which is consumed by resistors in this case. That's the scheme. I hope it's clear. And at this moment we can see that first maybe measure once again the voltage drop, which is 9.63 on the first one and 9.75 on the second one. So, but the flowing current is pretty high at this moment. It's 120 milliamps. Yeah? So let's perform the last experiment. So all resistors which I used today, they had only 1 watt. So I choose one, which is 5.1 ohm, and let me show you what can happen if you will incorrect use a resistor. Watch out, don't try at home. Flowing current is above 2 amps. That's a lot. We are talking about the 20 watts of the power consumption. As you can see, barely it's burnt, just carbonized. It could cause a fire, so be careful. Thanks a lot for watching. I hope to see you in next episodes. Like and share.